Can we begin? It's 4 o'clock.
Yes, ma'am. Good evening, everyone. The Intergovernmental Panel on Climate Change, IPCC, has submitted its sixth annual report on 9th August 2021. The highlights of the report are human activities are unequivocally causing climate change, and the world is likely to witness 1.5 degree centigrade warming limit within 20 years. Global warming is dangerously close to spiraling out of control. UN Secretary General Antonio Guterres described the report as code red for humanity. The alarm bells are deafening, he said in a statement. I quote, "This report must sound a death knell for coal and fossil fuels before they destroy our planet." Unquote. The report evoked a host of reactions from the heads of governments to environmentalists. What are the findings of this 3,949-page report, and what is so alarming about it? To get a deeper understanding on the issues of climate change, its patterns, causes, effects, and climate resilience pathways, we have put together a two-day webinar titled Symposium on Intergovernmental Panel on Climate Change, IPCC. Let me introduce my team. We have Ms. Seema Nagpal, heading Physics Department, Ms. Monia Seni, heading Chemistry Department, and Ms. Shobha Chandra, our Academic Coordinator, and myself, Bhaskar Valli, Head of the Department, Science. We have amidst us Ms. Mugdha, who is a Senior Consultant with Ernst and Young. She has 7 years of experience in the domain of climate consulting with in-depth expertise in the areas of carbon tax modeling, climate change mitigation and resilience, carbon emissions assessment and industrial low carbon development. Ms. Mugdha has worked extensively with international financial organizations like the World Bank, United Nations Environment Programme, United Nations Industrial Development Organization, GIZ Germany, leading projects on industrial decarbonization and resource efficiency, climate change strategy development across South and Southeast Asia and West Africa. She is an economist and holds an MPhil in environmental economics from University of Bath, UK, and an MSc in financial economics from University of Exeter, UK. She is pursuing PhD from McMaster University, Canada. Her specialization is in guiding projects for environmental sustainability. We welcome you, ma'am. Before taking the first topic of the two-day session, I would request Ms. Mugdha to share few thoughts on the IPCC's AR6 Climate Change Report. Over to you, ma'am.
Thank you so much. And first of all, I would like to thank you for the opportunity of inviting me to for this webinar today and as well as tomorrow. And I applaud all of you trying to invite students to understand about climate change at a young age and also from school. My thoughts on the AR6 is that it really is a wake-up call for us all right now. And this is a time where we need to invest more of our capacities and more of our knowledge, as well as the future capacities of our students to understand how to mitigate climate change and climate disasters. It is unequivocal, like you said, that human causes are causing, anthropogenic causes are causing climate change, and it can be felt especially in countries like India and Bangladesh and other South Asian countries. as well as now in Europe and North America. And we have seen that flooding and cold spells and hot spells in UK have really opened the eyes of the global community to the impacts of climate change, which until now were mostly thought to be a developing world problem. But now it's clear that it is a world problem, a global problem. And the AR6, for those who would want to read this, I would suggest that at least go through the summary report to understand what kind of challenges that the human race faces now, and also what are the things that we need to do and how fast do we need to do them. There are very good initiatives that the Indian government is taking, for example, to mitigate climate change and also to build capacity and resilience, not just at the coastal communities, which are very much in danger, but also across India as well, be it North India or Northeast India, where deforestation, for example, has caused a lot of soil erosion, as well as it causes a lot of biodiversity loss, which directly or indirectly does involve human impact, because we are the ones who are doing this to our planet and to our environment, and we need to step up. And time is short. I think we were given about 30 years, and out of those, about 15 to 20 years have gone. So I think that's a good place to start. We have to understand what climate change is. We have to understand what we can do as a society, as a collective, or even as citizens, that to elect governments that work towards climate change mitigation and adaptation. I think so. These are my initial thoughts, and I think we can take this up in the last session of this. Yeah, thank you so much.
Thank you, Mugga. It is very nice that young people are now going into the zone of climate change and environment. And today only I read in a paper that at least 220 health journals, international health journals across the world, have joined together for a clarion call that unless and until all the governments put together their efforts to get the governments to understand that do not go beyond the temperature rise of 1.5 degrees Celsius, we are only looking at an impending disaster. As if they weren't enough already. You could see that from North America to Japan in the Northern Hemisphere, and in the South, from one continent to another, what is happening. So today, Salvan Public School Mayur Vihar Science Department is putting up its thoughts on the IPCC report. And I'm sure that we'll be happy to hear from your expertise on climate change. Over
Thank
to
you so much.
Thank you, ma'am. I would now like to ask the audience, what comes to your mind when you hear the word climate change? I would request you to participate in building up word cloud on menti.com. I have pasted the link in the chat box. You just need to click on the link, and whatever word or thought or feeling comes to your mind, please put it over there. Just click on the link which is pasted. Yes. So the words have started coming in, and global warming, flash floods, climate change. Yes, more participants to come in. Just click on the link and submit a word. Just a word you need to type and submit. So the cloud is building up with your active participation. Some more participants to put in the words. That's nice. Yeah. So the word cloud is getting bigger and bigger. I can see so many words related with climate change. Thank you so much for your active participation. Thank you so much for your active participation. So, if we look into each of these words, there is one underlying emotion, and that is fear, concern about our own survival as human race. Before we ponder over the findings of IPCC report, we need to understand what is climate and how does it change. Climate is the long-term pattern of weather in a particular area. Weather can change from hour to hour, day to day, month to month, or even from year to year. Distinct weather patterns are, however, observed over 30 years or even more. So, climate is mostly constant. This allows the living organisms to adapt and thrive on this planet. However, climates do change. They change very slowly, over a span of hundreds or even thousands of years. When do we say that the climate has changed? When the concentration of greenhouse gases like carbon dioxide increases in the atmosphere, when land and ocean temperatures increase, when sea level rises, when the glaciers melt and retreat, and when we witness extreme weather conditions. Let us look into each one of these events. As we can see from the graph, the carbon dioxide levels in the atmosphere have been relatively constant for thousands of years until 1850. Next slide, please. When industrial revolution was still in its infancy, the carbon dioxide concentrations were only 280 parts per million. From then on till 1950, the growth was nominal. It rose from 280 parts per million to 320 parts per million, roughly 0.6 parts per million per year over a span of 100 years. That is very nominal. However, from then on, there has been a phenomenal rise. The growth rate in the past decade has been recorded at 2.3 ppm per year. In 2010, carbon dioxide concentrations at the Mauna Loa Observatory in Hawaii were 390 ppm, and by 2018, these levels reached well beyond 400 mark. The global atmospheric carbon dioxide reached as high as 410 parts per million in March 2019. Rise in carbon dioxide levels. What do? They trigger temperature rise on the surface of the earth as well as the sea. Carbon dioxide is a greenhouse gas and it absorbs and radiates heat. When Earth's land and ocean surfaces get heated by sun, they continuously radiate this heat. The greenhouse gases absorb this heat and release it gradually over time, just like bricks in a fireplace after the fire goes out. With increase in greenhouse gases in the atmosphere, additional heat gets trapped and this leads to a rise in Earth's average temperature. Climate and sea levels were relatively stable. Next slide, please. Up to 19th century. However, the average global temperature rose by around 0.8 degrees centigrade between 1850 and 2012 over a span of 160 years. The rate of warming was more marked from the mid-1970s, and each of the most recent 3 decades have been warmer than all the preceding decades since 1850. The 10 warmest years on record have all occurred since 2005, and 7 of these 10 have occurred just since 2014. The last decade has been the warmest of these. Globally, 2016 and 2020 were the hottest years on record. Not only the temperature of land, but also the oceans is on the rise. The greatest ocean warming has taken place between 1971 and 2010, with the upper 75 meters of the ocean warming by an average of 0.11 degrees centigrade each decade. Due to this warming of the ocean, the sea ice has plummeted to its record low. Sea ice is ocean surface water which is frozen, and this grows during the winters and melts during the summers. In the Arctic Ocean, the sea ice extent, that is the area of ocean which is at least covered with 15% ice concentration. Typically, this sea ice extent reaches its maximum in March and minimum in the month of September every year. We have data from 1970s as satellite record measurements began only in the late 1970s. Ever since, Arctic sea ice extent has decreased in all months and virtually in all regions. The 14 lowest minimum extents have all occurred in the last 14 years. Not only this, the ice that survives year round has become thinner and more fragile than it used to be. Cold spells lasting more than 15 days have almost completely disappeared from the Arctic since 2000. The Greenland ice sheet is also continuing to lose ice mass. In total, approximately 152 gigatons of ice was lost from the Greenland ice sheet between 2019 and 2020, just in a year. Antarctica is losing approximately 175 to 225 gigatons ice per year. The world's largest iceberg, A76, with a surface area of around 4,320 square kilometers, which is almost thrice the size of Delhi, has broken off from Antarctica in the month of May 2021. The melting of ice has resulted in rise in the sea levels. Average sea levels have risen about 9 inches since 1880. The rate of sea level rise is accelerating and has more than doubled from 0.06 inches per year throughout most of the 20th century to 0.14 inches per year from 2006 to 2015. It is due to these climate change events that we have witnessed some extreme weather conditions. My colleague Shobha will take you through some of these extreme weather events. Over to you, Shobha.
Thank you, Ms. Valli, for explaining the factors causing global climatic changes. And as a result of these climatic changes, extreme weather events have become more frequent and severe all over the world. In the year 2020, heavy rain and extensive flooding occurred over large parts of Africa and Asia, the Indian subcontinent, and the neighboring areas like China, Korea, and Japan. And parts of Southeast Asia also received abnormally high rainfall at various times of the year. A recent slow-moving rainstorm in the mid-July 2021 caused rivers and reservoirs to spill over the banks, leading to deadly flooding in central China. Devastating flash floods caused by the heaviest rainfall in Germany and Belgium left hundreds dead and several thousand missing and thousands more stranded and homeless in Western Europe. Streets turned into rivers, causing several shops and houses to collapse. The flooding caused damage in the Netherlands, Luxembourg, and Switzerland also. Floods have ravaged several states across India, including Maharashtra, Madhya Pradesh, and Bihar due to torrential rains. Jammu and Kashmir, Uttarakhand, and Himachal Pradesh witnessed cloudburst and landslides. The second extreme event that I'm going to talk about is the devastating droughts. Severe drought affected many parts of the interior of South America in 2020, with the worst affected areas being northern Argentina, Paraguay, and the western border areas of Brazil. The estimated agricultural losses were nearly $3 billion in the Brazil itself. Long-term droughts continue to persist in almost all the parts of Africa. Climate change has been a key factor in increasing the risk and extent of wildfires. My colleague also told us that in the large region of the Siberian Arctic, temperatures in 2020 were more than 3 degrees above average, and this was accompanied by prolonged and widespread wildfires. In the United States of America, the largest fire ever recorded in late summer and autumn. Widespread drought contributed to the fires, and July to September were the hottest and driest on record for the Southwest. The Death Valley in California reached 54.4 degrees Celsius on 16th of August, the highest known temperature in the world in the last 80 years. In the Caribbean, major heat waves occurred in April and September. Cuba also saw a new national temperature record of 39.7 degrees Celsius, whereas Australia also broke heat records in early 2020, including the highest observed temperature in Western Sydney. Similarly, the summer was very hot in parts of East Asia, Europe, Eastern Mediterranean, and thus experienced drought and heat waves during summers 2020. Kuwait and Baghdad in the Middle East, Sindh province of Pakistan, saw temperatures rising well above human tolerance at a life-threatening 52 degrees Celsius. Several other countries like Siberia and Algeria have also reported their worst and largest fires in the recorded history. Ms. Valli also explained us this chain reaction that increase in carbon dioxide leads to increase in temperature, which gives rise to strong winds and dry weather leading to wildfires. Climate changes has made the US West warmer and drier in the past 30 years and will continue to make the weather more extreme, the wildfires more devastating, according to the scientists. Forest fires are also raging Turkey, Siberia, Lebanon, France, to name a few. So you see, no part on the earth remains unaffected. The wildfires are spreading and engulfing every region on this planet. The fires actually create a vicious cycle. Burning increases the carbon emission while also destroying trees and other ground cover that can absorb the greenhouse gas. Dead trees will continue to release carbon they once stored. So you see, it's double the loss. One, that forests that act as a carbon sink that absorb the carbon are being burnt. And second, that these burnt forests release carbon into the atmosphere. And it doesn't end here. There has been a sharp rise in dreadful hurricanes and tropical cyclones, cloudbursts all over the world. With 30 named storms, the 2020 North Atlantic hurricane season had its largest number of named storms on record. There were a record 12 landfalls in the United States of America. Hurricane Laura in Central America, Cyclone Impha near India-Bangladesh border, Typhoon Goni across the northern Philippines, Cyclone Harold and Fiji, Tonga and Solomon Islands, Storm Alex in western France, and other major severe storms in Canada and Libya has been extremely devastating, causing loss of life and property worth thousands of billions of US dollars. So it is very evident from this scientific data that the climatic changes are leading to extreme weather events. And now I would request my colleague Ms. Seema Nagpal to explain it further, that why, while some parts of the world are flooded, there are some parts which are experiencing drought. How these climatic changes disturbs the water cycle and causes devastation. Over to you, Seema ma'am.
Thank you, Shobha ma'am. I'll be discussing about the impact of climate change on water cycle. And good evening, everyone. As we can see in the slide, that ocean contain 97% of the Earth's water. Heat from the sun causes the water to evaporate. Water vapor rises and condenses as clouds. Water droplets fall from the clouds in the form of drizzle, rain, snow, or ice. Snow or ice accumulate, later melting back into liquid water and turning into vapor. Water flows above the ground as runoff, forming streams, rivers, etc. Plants take up water from the ground, later transpire it back to the air. Water is soaked into the ground, seeps back, and rich in minerals. Water penetrates the Earth's crust and comes back out as geysers. Now the question arises, now as we have seen in the previous slide, that water is always on the move. Water is in atmosphere, on the land, in the ocean, and underground. It moves from place to place through the water cycle. Now the question arises that does the climate change impact the water cycle? The answer is yes, the climate change impacts the water cycle. It affects the evaporation and precipitation. As the air temperature increases, more water evaporates, and warmer air can hold more water vapor, which causes extreme flooding in the coastal areas. And also, in case of dry areas, when the temperature increases, more soils dry out, leading to droughts in the drier areas. On the whole, we can say wet areas are expected to become wetter and dry areas drier. Now, in order to understand the impact of climate change on water cycle, let us have a look on feedback loops. What is a feedback loop? It is simply a loop of cause and effect. As we can see in the figure, when our body temperature increases, we start sweating in order to decrease our body temperature. Similarly, when our body temperature decreases, we start shivering in order to increase our body temperature. This is an example of negative feedback loop. In context of climate change, there do exist feedback loops. Feedback loop is something that speeds up or slows down a warming trend. There are two types of feedback loops. One is positive feedback and other is negative feedback. Positive feedback accelerates the temperature rise, whereas negative feedback slows it down. Now let us have a look on few examples of feedback loops. The first one is ocean warming. As we can see in the figure, when the carbon dioxide level in the atmosphere increases, it leads to warmer atmosphere. Warmer atmosphere leads to warmer oceans. But the ability of the oceans to absorb the carbon dioxide decreases with the increase in temperature. Hence, the carbon dioxide level in the atmosphere keeps on increasing. Thus, ocean warming is an example of positive feedback loop. Next one is cloud cover. As we can see in the figure, high clouds trap more heat, but low clouds reflect more heat. Thus, cloud cover can add on to the greenhouse effect by absorbing more heat. And they can reduce the warming by reflecting the solar radiations back into the space. Thus, cloud cover can be the example of positive feedback loop, provided they are located at higher altitudes. But if they are located at lower altitudes, they are an example of negative feedback loop. Next one is shrinking sea ice. Now, as we know, sea ice provides wide surface for the solar radiations to be reflected back into the space. And as the sea ice starts melting, it exposes the dark ocean surface and which absorbs more solar radiations, and hence more warming takes place. Further, more melting of sea ice takes place. Thus, shrinking sea ice is also an example of positive feedback loop. And there are predictions that there may be no more sea ice left in the Arctic Ocean during summer within next few decades. Next one is melting permafrost. Now, what is permafrost? Permafrost is the layer of soil which has been permanently frozen in cold areas. And as this permafrost starts melting, the carbon trapped inside the soil is released in the form of carbon dioxide and methane. And methane is 25 times more powerful gas than the carbon dioxide. Thus, melting permafrost is an example of positive feedback loop. Feedback loops are even more complex when taken as a part of integrated global climate system. If the global temperatures continue to rise, some of the feedback loops could spiral beyond our ability to reverse the warming. Now, my colleague Monia ma'am will be discussing about the causes of climatic change. Over to you, Monia ma'am.
Thank you, Ms. Seema. As my colleagues have discussed about the various events of global climate change, it is also important for us to understand its causes. So what causes Earth's climate to change? And the answer is emission of greenhouse gases. Greenhouse gases acts like a heat-trapping blanket, making the Earth habitable for humans, which is a necessity. But excess production of these gases cause global warming. There are numerous greenhouse gases like carbon dioxide, which is minor, but very important component of the atmosphere. Carbon dioxide is released through various processes. This is the most important long-lived force that leads to the climate change. Methane. It is far more active greenhouse gas than carbon dioxide, but is much less abundant in the atmosphere. Nitrous oxide. It is most powerful greenhouse gas produced by various soil cultivation practices. Chlorofluorocarbon is a synthetic gas entirely of industrial origin, which is used in number of applications like refrigeration, air conditioning, contributing to destruction of ozone layer and eventually leading to global warming. Water vapor. It is the most abundant greenhouse gas, but importantly, it acts as a feedback to the climate, which has been elaborately discussed by Ms. Seema. The sources of these greenhouse gases can be divided into two categories, natural and anthropogenic. Let us first discuss the natural causes. Solar activities. The energy output of the sun is not constant. It varies over time, and this has an impact on our climate. Ocean current. They act as a conveyor belt of warm and cold water, and sending the heat towards the polar regions and helping tropical areas cool off, thus influencing both weather and the climate. Earth's orbit. Shifts and wobbles in the Earth's orbit around the sun also affect the amount of solar heat that reaches the Earth's surface and subsequently affecting the climatic patterns. Volcanoes also affect the climate through the gases and the particles that are thrown into the atmosphere during their eruptions. Meteorites have also impacted the climate change in the geological past, and the good example could be Chicxulub crater, Yucatan Peninsula in Mexico, which released huge amount of dust and aerosols into the atmosphere. These causes have always been there and are responsible for periodic heating and cooling of the atmosphere, but there is nothing much we can do about them. Coming to the anthropogenic causes, the majority of the carbon dioxide comes from burning of fossil fuels. People use fossil fuels to drive vehicles, generate electricity, manufacturing purposes, etc. Fossil fuel contains carbon dioxide that has been locked away in the ground for thousands of years. When we take these out of the land and burn them, we release the stored carbon dioxide into the atmosphere. Urbanization. Urban population consume large number of goods and services, leading to emission of various greenhouse gases. Cities only emit around 60% of the greenhouse gases, catering to the residential needs. Agriculture. Livestock produces significant amount of methane as a part of their normal digestive processes, which stays in the atmosphere for a long period of time. Nitrous oxide is also produced from commercial and organic fertilizers. It is 10 times worse and 300 times more powerful than carbon dioxide. Land uses. Replacement of darker forests with paler croplands and grasslands also contribute towards the emission of greenhouse gases. Trees help us to regulate the climate by absorbing carbon dioxide from the atmosphere. When they are cut down, the beneficial effect is lost, and the carbon stored in the trees is released into the atmosphere, adding to the greenhouse effect. Forests store around 283 gigaton of carbon as biomass, 38 gigaton in dead wood, and 317 gigaton in soil and accumulated litter, which is released when we burn them. Next slide, please. Here is a pie chart which shows the contribution of various sectors towards greenhouse gases, and the leading one is electricity and heat industry, followed by agricultural industry. These causes have increased in the last 2 centuries, which is of a greater concern. The impact of human-induced drivers of climate change have been much larger than the natural drivers over the last century, and the same has been concluded by the IPCC. Now, because the primary cause of the recent global climate change is human, the solutions are also within the human domain, which paves the way for effective solutions to be developed and deployed, which we will be discussing in tomorrow's webinar. But before ending, Let me quote Kofi Annan, former Secretary General of UN. The world is reaching the tipping point beyond which the climate change may become irreversible. If this happens, we risk denying present and future generations the right to a healthy and sustainable planet. The whole of humanity stands to lose. Unquote. So thank you so much, everyone. Now, I would request our resource person, Ms. Mugda, to share her thoughtful insights on climate change. Over to you, ma'am.
Thank you so much, and thanks for a great presentation. It was really informative. Everything that you presented is essentially the basics of what students should learn about climate change. And I would just like to give an example about the impacts of climate change that we usually forget, I think, because we are so caught up in the major events like droughts and famine and deforestation that we sometimes sort of forget. And even when it comes to disaster events, we somehow forget how that impacts us out in our daily life. So I have been living in Delhi on and off for the last 30 years. And I would just like to give an example of how climate in Delhi has changed. And it's very subtle. It's not something that hits you right in the face. But there are if you pay attention, there are a lot of clues that can point you towards the impact of climate change. For example, when I was younger, there used to be something in Delhi called Loo, which is essentially hot, dry winds that would run through the city for a couple of months in June and July. We don't really see that anymore. And our summers have now become longer, yes, but they have also become more humid and wetter. And that is also seen in the pattern of monsoons that we have in Delhi. We used to have very set monsoon periods in Delhi, for example. I think some of you might even remember that. But now it's kind of all over the place. It's raining in March, it's raining in February, it's raining in April, when it would usually start towards the end of June and end towards the end of August and the beginning of September. Now rainfall in Delhi is much more scattered, and the impacts of that is that we have high humidity periods for a lot of the year. Then we also have had less formation of fog, for example. Some of that does have to do with the introduction of more vehicles in the city, and which causes pollution and essentially leads to smog. But if some of the teachers would remember, we used to have fog that you couldn't see through it, essentially, and that was the way it was, and we don't really see that anymore. And which also dovetails into the way winter, for example, has changed in Delhi. We used to have really cold winters for at least 2 or 3 months. Winter has now been pushed further and further back. It used to start towards like the end of October. Now it's towards the end of November, sometimes even December. So summers have gotten hotter and warmer, and well as better. And winter also has gotten warmer. And the extent and the impact of winters that we used to have in Delhi has completely it's become more moderate. Let's say it's become more temperate. The other thing that I have noticed in Delhi is that there are no insects anymore. And that could be because of the use of a lot of pesticides and a lot of insecticides in our cities, and also a lot of built up environment. There is a lot more development now than there has ever been in the last 30 years. However, the impact is more subtle. You don't see sparrows anymore. You don't see insects in the monsoon seasons in Delhi anymore. And all of this does have to do with climate change, indirectly or directly. Even the built environment that we have in Delhi, for example, the more malls that have come up, and the more development that we've had on the edges of the city, it really does cause the forest loss to be more noticeable. Delhi lies between the Yamuna floodplains and also the Delhi Ridge, which is the Delhi Ridge on one side and also the Aravalli range on the other side. So it was in a very good spot. However, in the last few years, the amount of development that has happened in the capital city has really exacerbated the problem of dust, for example, and that mixes up with pollution from the traffic and pollution from construction and debris, and it actually contributes to more warming of the city. Now imagine this on a global scale. This is exactly what's happening in all of the major cities in the world. And you would be forgiven to thinking that climate change only occurs because we cut down forests, or the ice is melting in the Arctic. But that's really not the case. A lot of climate change effects can be traced back to the built environment that human beings have created now all over the globe. An interesting statistic on this is that the weight of all the built environment that human beings have created now outweighs all of the biodiversity, all of the plants and animals on this planet. And that is something that would be unimaginable even 10 years ago. And that is something to really be cognizant of. So we need to work with nature, and cities, unfortunately, are not the conduits for it at this stage. A lot of climate change mitigation starts from the cities, mostly because of we have governance here, and we have built environments, and we can initiate policy responses. But beyond cities, I think a lot of climate change mitigation and adaptation needs to happen on a cross-cutting basis. So you need not only focus on one aspect of the supply chain, you should focus on multiple aspects of a supply chain. I'll give you an example when it comes to the use of cotton. Now, we think that cotton bags are much more they are much more sustainable than, let's say, single-use plastic or even polymer bags. But we have to look at it from a very life cycle analysis kind of way. So, and this is interesting. I would suggest that people should go look this up. But the overall impact of using a cotton bag versus, let's say, a single-use plastic bag can only be adjusted if you use that cotton bag 4,000 times. And that's something we'd never think about. Using a cotton bag 4,000 times is something that we wouldn't even do. After maybe a year or two, we would change it. So where does that cotton bag go now? It goes back to the landfill. So, and then it releases emissions over there. That's downstream. Let's talk about upstream, how cotton is made. So what I work in, especially in industrial decarbonization, is trying to understand how we can decarbonize the processes of manufacturing. Cotton, for example, uses a lot of water, not just at the point of its growth and point of its cultivation, but also how it is processed and how it's brought to us in the form of fabric or bags or quilts or t-shirts or even jeans. So it's important to understand how we can decarbonize upstream. And this is what we're also trying to do. So a good way to understand your impact or understand a person's individual impact is also to understand how we fit into the larger supply chain.
Have you lost the resource person link?
Yes, I guess the ma'am is not there. So
Okay.
she dropped the call.
So I'll take it further. This is very interesting statistic. And also one of the teachers, I don't remember who was saying that, but I would like to just add a point to this. It was probably the feedback loop. If you remember, it was about the permafrost. When you say that the permafrost is declining, a very large area used to remain under permafrost throughout the year, particularly in the Arctic area and the Antarctic zone. Antarctica always, it has been a continent which is not inhabited, but people do live on the edges of the Arctic. So this permafrost, which is slowly disappearing, it is melting away. Many of the governments might think that it has added to their growing period of a particular crop. A lot of places in the colder countries, the farmers rejoice the fact that the winter is not as bitter and as frigid as it used to be earlier because the permafrost is melting. But all my dear students out there and all the audience, what happens, whatever nature has given to us, the environment, based on the typical heat zones that we have, if the human interference, the anthropogenic factors intervene with it, then that is not going to be sustainable for a long time. It is all right that there are areas which never had a growing season of 6 months or even 5 months, and now they have for 7, 8 months. But all my dear students must understand that is causing a lot of dangers to the environment. Sea levels are rising. And that's the reason. The soil, which was never used earlier for growing crops because it was under permafrost, is now being exposed. And when it is exposed and used for farming, it will have impact. It will have implications. It is all right for some governments to say that the Arctic Sea, the Arctic Ocean has opened for the world trade because the ice is melting. But look at the trade-off. Look at the cost. The cost is when the Arctic ice melts, the icebergs break, and they add to the sea level, then what happens? All those large ships and tankers, which never used to go from there, are now passing. And what do they leave in the trail? What do they leave behind? A terrible mess detrimental to the environment. The oil spills. Therefore, today's webinar was organized for all those students who wanted to understand that climate change has a cost. And the cost is not just economic. It is definitely bad for the economics. But it is not only economic. It is human cost. It is a cost on the health. It is cost on all of us. And that is why the health journals, when they say that the governments take adequate steps to ensure that the world average temperature doesn't go 1.5 degrees Celsius beyond the normal average, they have a point. And the governments need to listen. But my dear students, it is not just the governments who have to listen to us. All of us, each one of us has a role to play. And I hope that in this discussion, we will be able to make you aware of how climate change is detrimental for the very existence of mankind. So that's from my side, Valli. Please bring it to the conclusion now.
Thank you so much, ma'am, for your valuable insights into climate change. You spoke about permafrost, you spoke about the melting glaciers, and that was really, insightful. So I thank all the parents and students who have joined the webinar today, and also Miss Mugdha, our resource person. I think she got disconnected and she is not there now.
Now she's there.
She is there. Okay. Thank you so much, Miss Mugdha. It was really wonderful, to hear you. And I think it was really undoubtedly a great learning experience for all of us today to hear from you.
Thank you.
I thank you for sparing your valuable time and gracing the occasion with your presence. Thank you so much.
Thank you very much. So I will see you all tomorrow at the same time. We meet again at 4 o'clock. Thank you very much.